Hello, my friend, and welcome back to 3D Printing 101. So, in this lesson, we're going to be going over the basic principles that you need in order to 3D design. Now, we're not going to go super in depth. This is just going to be the basics, but it's going to allow you to build the foundation that you need in order to actually build practical things and things that are going to, eventually change the world. So, without further ado, let's get into it. So, for 3D design, you're going to be using what's called a CAD. CAD just means computer aided design. So a CAD software like Fusion 360 or even Tinkercad or SketchUp or Blender, all of these are what are going to allow you to turn your ideas into reality. It's just the notebook, the pen and paper. These are the tools that you're going to use not to come up with the ideas, not to design, but in order to make that design a real tangible thing. So just look around, look for all of the manufactured items that there are around you. It doesn't have to be something that you 3D printed, but headphones, a mouse, water, not the water itself, but the glass that holds the water. All of these things were made in part with the help of CAD. It's totally transformed the way that we make things today. So for things like the glass, somebody used CAD most likely to design a glass mold or some sort of device, machinery that allowed the glass to be made. If we look at the 3D printed part, obviously somebody modeled this, but they also modeled all of the machines that make the machine. They also modeled the machine and all of the parts within it. So there are a lot of layers to this. Headphones, someone modeled each individual part of this. They most likely what they did is they made a basic model for the headphones themselves, and then they separated that into the different groups. Like these muffs are made of a different material. They're like fake leather. They're made of a different material than the part that they're sitting on. And within that, there are speakers and batteries, and you can actually include parts like that, like speakers and batteries, in your CAD software. A lot of CADs even have their own library where you can download an item. So say you wanted to download the model for a 9-volt battery, you wouldn't have to design that yourself. If someone has already designed that, and I'm sure that somebody has because it's a very, very common thing, you can just download it, import it into your model, or your assembly. Your assembly is just a compilation of multiple models that you can create, and that's what allows you to make things like a system or just more complicated parts that require multiple different pieces that are going on. Again, back to these headphones. These headphones definitely had an assembly because if you're just designing all of the parts individually and you're not seeing what it looks like as a whole, one, you're not going to know what it looks like when it comes out, and you're not going to be able to see the sizes. But two, you don't even know if you made a mistake or something, you won't know until you actually make the thing and try to put it together. So an assembly is super helpful. As you can see, CAD and different design softwares are essential in almost everything that we use today. So make note of that, just how the level of importance of this skill in the world. And it's going to remain important for forever. One day AI might be able to do this, but it's going to be a minute. So this skill is probably one of the most important ones in the world. There are two basic design principles that you need to know. The first one we already covered, and that's divide and conquer. This is just a strategy where you take a complex shape and you break it into different parts that are more easy to understand. So like we did with the wrench. The wrench, we had this very complex part, and it was kind of this amorphous thing. We didn't really know how to attack it at first. But instead of sketching out all the individual parts, we could break it into, okay, here's a rectangle, here's a circle, here's another circle, here's a hexagon, here's a star. So we broke it down into all of these simple parts. And a lot of different things are like that, not just things like a wrench, but when you actually take a look at things, like look around, like even things that you might not have thought of, even like going away from 3D modeling and 3D objects, things like art. This is something that is taught in art. When I'm taking art classes, they have clearly said, break this down into simple shapes. So if you take a look at the human head, you have a circle, and then you've got, lines, like there's a line here, line here. There are basic proportional lines that are important for aligning the rest of it. You've got triangles, circles, ellipses, but if you break it down to those simple objects, it becomes much easier to tackle, and you actually end up with a better design. The next strategy you need to know is KISS, the KISS strategy. I'm sure that you've heard this somewhere before, but if not, keep it simple, stupid. Keep it super simple. Basically, it just means don't overcomplicate your designs. There is no award, unless you're in like a Rube Goldberg machine competition. There is no reward for the most complicated design. There's only the reward for the best working design. And usually when you have more, complexities, more weird things going on, it's more difficult to control, and you end up having more failures because there are more things that can go wrong. So it's going to take you longer to make more complex things. It's not going to work as well. And that's it. But that should be enough, right? Keep it simple, stupid. Just remember that, and you'll be ahead of 80% of people. Now, zooming in, taking a closer look at the actual 3D modeling aspect of this, the first step to that is sketching. Sketching is what allows you to make 3D objects without, just bringing in cubes and things like that. When we were designing our keychains, we just brought in 3D objects, and that's okay. That works. And for, things like Tinkercad, that entire software was made around letting people do that because it makes sense. But really, the first step that you're going to do for most of your designs is sketching. So taking a look at your 3D object and deciding what is the most sketchable area for this. And usually when you're determining that, if you take a look at your 3D object or what you want it to be, your design, your thought process, what is the biggest area and which one has the most shapes? If you're designing this Altoids lid, you don't want to sketch it from here or here because that's not going to give you that much information. You're probably going to want to sketch it from here because, first of all, it's a very large surface. So usually those large surfaces are going to have more things going on in them. But also, like if you take a look, very few things are going on here. Many things are going on here. So if you sketch it from this perspective, then you can just extrude it and you'll already have the majority of it done, the majority of the work. When we're sketching, it's basically just like drawing. If you can draw stick figures, you can draw this. Honestly, you don't even need to be able to draw stick figures because it's all within the software. So there are line tools, rectangle tools, circle tools, basically all of the basic shapes that you're going to need, and also tools for creating arcs and more complex shapes. So you don't even need to be good at drawing to do this because you can just use the tools and go through the process and it will still work for you. Now, once you have that sketch, we need to make it three-dimensional. And to do that, you're going to need to either extrude or to revolve. Extrusions are just turning your sketch into 3D by pulling it or pushing it. So if we again, take a look at this Altoids lid. If we have the sketch, if this is our sketch, then we need to pull it in this direction in order to make it a 3D object. Otherwise, it's just going to be this flat thing, and you're not going to be able to do anything with it. You can also revolve. So we'll get more into this in a later lesson, but revolving is similar to extruding, but it allows you to do it around an axis. So this is useful for, creating wheels, circular objects. If I were to design this lamp, I would use the revolve tool. I would first sketch half of it and then revolve it around this axis. And again, you don't need to fully understand this right now because we'll get into it later on, but know that it is a possibility. Another way to make these sketches three-dimensional is from lofting and sweeping. So basically what this allows you to do is it allows you to define the path that you want a sketch to move, and then you can take, that simple sketch, let's say it's a circle, and move it along that path. We'll get way more into this in another episode, but this is what's going to allow you to make things like horns or hooks. If you're designing this clothes hanger, it's going to be really difficult to do this just by sketching and extruding or even by revolving. But what you can do is you can define this path and then make, if we look at the cross section here, this is just a circle. It's just a circle wire that they bent in this shape. But if we were trying to 3D print this, we would just sketch a circle right here and then pull it along this path. This is just going to allow you to make more complicated shapes. Fillets and chamfers. These are two small examples of details that you can add to your print to make them more refined. So there are different methods of doing this, and there are different applications. You can use these along with other tools to make some really cool effects. But a fillet is just the curve that you'll see on an object. If you have a perfectly sharp corner, a fillet is just going to curve that. A chamfer is similar to a fillet, but what it does is it takes this and it's almost like it takes a cut, an angled cut out of the side of it. Both of these are going to, one, make it more aesthetically pleasing, two, make it safer, make it something that's going to be wearable. It'll make it more comfortable, and it will also make things work better in a mechanism because it'll kind of force things to work together. If you've ever looked at a door mechanism, like the handle for the door, the latch isn't perfectly straight. It's curved, well, just a little bit, and that allows it to, when you shut the door, it pushes it in until it latches into place. So there are tons of applications for this. Some important design considerations while you're actually doing this that are a little bit more broad, but they're going to allow you to make better designs. The first one is usability. So make sure that you're focusing on how the user is going to use this. And this kind of ties into human-centered design, which is just designing your products around humans. For example, these are 8-foot ceilings. Those are 8-foot ceilings because the average human is between 5 and 6 feet tall. If humans were 2 to 3 feet tall, then these ceilings would probably be 4 or 5 feet. That's just because of who we are. If we were 10 feet tall, these ceilings would be 12, 13, 14 feet. But usability is focusing on the function and form of the object and just constantly being in the state of is this what's going to help with the end goal of this product? And if not, then don't do it. If it is, then you can proceed. Tying into this are ergonomics. Ergonomics, you probably usually think about this like, oh, my chair, my desk setup, it's got to be all lined up and everything. And that is correct. But if you take a look, for example, at this mouse was clearly designed to be ergonomic because it's perfectly shaped to a human hand. If it were Like the Apple mouse. The Apple mouse is notoriously not like good designed for your hand. It might look pretty, but something like this is going to give you a lot more support, and it just works better. It's a very natural positioning for your hand to be in. So constantly thinking about this, if your product is going to be, if you're going to interact with this a lot, thinking about ergonomics is just going to let you level up. Next up is manufacturability. Can your part actually be manufactured on a large scale, or just efficiently and effectively? When you're designing something for 3D printing, there are less constraints. That's part of the reason that 3D printing was created, and part of the reason why it's so popular, because it was designed for rapid prototyping. So there are less constraints. Like for injection molding parts, there are a lot of constraints around the geometry of the parts. But with 3D printing, if there's something, especially if you're only printing one of them, then you can just add supports, or you can turn it. All these things that are not possible really with other manufacturing techniques. But if you're going to be printing a lot of them, for example, I had a business where I was selling 3D printed Jeep tow hooks, then you want to make sure that you're designing that in such a way that you can be 3D printing them day after day after day, maybe even printing hundreds of them sometimes. Even when you're printing a couple, it's important to kind of consider, okay, is this really the best way to do this for, my 3D printer, this thing that I'm using? Because, if at the end of the day, if the design's great but it doesn't print well, then what was the point? Like, so what? But especially when you're looking at larger number of parts, larger applications, definitely consider this. The last main point that you might want to consider when you're designing your parts is environmental impact. This is, again, more useful and more important when you're thinking about printing a lot of something. But you want to consider, is there lots of waste? Just the most basic one. Do I need all of this, or can I maybe put holes in here strategically to reduce the amount of material that's used? This isn't just going to protect the environment, it's also going to cost less money, and it's going to save you from running out of material more quickly. The next thing is this going to break down quickly? If something is going to break quickly, it's not going to be as environmentally friendly, because you're going to have to keep replacing it over and over again. If this is a part and you can't really get it to, be 100%, like this will never break down, is it easily replaceable? Like certain objects, you can't really replace them well. But if you design it in such a way that you can fix something after it's made, that means you don't have to replace the entire thing, even if something does wear out. And realistically, something will usually wear out. So just to wrap things up, we went over different design strategies and the principles of design, how designing things actually works, and then some considerations that you want to have when you are designing. With this foundation, now we can go more deep into the different techniques that you need in order to design things for your projects. As you're going through this, share your progress with the community. I know I say it all the time, but this is the fastest way that we'll all level up, because if I learn from your mistakes, you learn from my mistakes, you learn from Sheila's mistakes, then we just all learn 3 times faster, because we're all learning 3 times the amount of stuff from 3 times the amount of experience. Multiply that by all of the people that are in this community, way more than 3 people, we can learn a lot faster. So thank you all so much for watching. I hope this was helpful to you, and I'll see you in the next lesson.